feedback again. We are discussing the properties of the feedback. So what are the most important things which we know about feedback so far? It reduces the gain. أولا. It reduces the gain. English ولا لا English خلاص It reduces the gain. طبعا ده عيب. لكن ايه بقى مقابل هذا؟ It increases the dominant high frequency board, which is good. It reduces the dominant low frequency board, which is good. مش كده؟ وايه كمان عملنا؟ It improves the stability of the amplifier to the extent that we can design an amplifier whose overall gain is totally independent of the gain of the original amplifier. And as such, it will be independent of variation in temperature, variation in supply, and so on. What else? عايزين نتعلم حاجة النهاردة جديدة. Of course, in any amplifier, we would like the input-output characteristic to be expressed as V naught equal to G times VI. It doesn't matter whether G is positive or negative, doesn't it? But it is a G times VI. G is a constant. So the relationship is a
linear,
a straight line. Slope equal to G. This is what we want in any amplifier, so that it will treat all the input voltages similarly. Input voltage small, input voltage large, it will be treated similarly. It will get the same gain. صح? The gain will not be affected by the amplitude of the input voltage. This is a linear amplifier. Linear amplifier. And this is what we want in amplifiers. Linearity is not always good, by the way. Inshallah, in other courses for 5.5, you will learn that linearity is not always good. Sometimes we design for non-linearity. But for amplifiers, linearity is very important because it means that input voltages are treated equally irrespective of their amplitude. You understand? In this case, the relationship between the output voltage and the input voltage is expressed as a straight line with a constant value G, which is the gain. But do you think that real life amplifiers are like this?
No.
طبعا لا. ليه؟ Of course, but أنا عايز أقول أنت
Offset
تقول
fault.
Of course, but عايز قبل كده كمان saturation. زي حسين قال لكم saturation. Eventually, the output voltage must reach saturation. The output voltage cannot exceed indefinitely. مش ممكن. It must saturate. That's right. So the output voltage eventually will saturate. طبعا at approximately VCC or VDD or whatever. Eventually, صح? Oh, by the way, oh معلش أنا كتبت غلط. Be out will be out. Be out. Although if we go with V out negative, it will go the same way. It will give us an output voltage which is negative if there is plus minus VCC. But if it is between VCC and 0, then it cannot go negative. So if the amplifier has these two DC supplies plus minus VCC, it can also go in the third line. Otherwise, it cannot because the output voltage cannot exceed 0, cannot go below 0. Because there is no minus DC supply.
Yes.
Right? But real life amplifiers have always that sort of saturation like this. And it doesn't go from linear to saturation suddenly as such. It will go usually through a curve like this. This is the characteristic of real life amplifiers. It is linear, but in a very small region of the input. But as the input increases, it will slightly start to be non-linear until eventually it will saturate. And it will be very hard on linearity. This is the real life amplifiers. طب is this nonlinearity good or bad? As I said, in 303 it is bad, but in 455 it is good. It depends on what do you want. I will give you an example. How can we express this nonlinearity mathematically? This one. How can we express this mathematically? أسهل حاجة تايلور سيريز. تايلور سيريز أسهل حاجة مش كده ولا إيه؟ وأسهل حاجة في تايلور سيريز the first two terms. لو مثلا A V out equal to V out equal to A times VI plus B times VI square. A now is the linear gain. A now is the linear gain صح؟ A now is the linear gain. ممكن أكتبها جي برضه ما أكتبها جي اللي هي دي صح؟ صح الأسلوب هنا as a small signal صح؟ plus B times VI square. We don't care now about how to get this B. This is not a big deal. But these are real life amplifiers. What's the consequence of having a real life amplifier with such a nonlinear characteristic? If VI is equal to A sine omega t, simple sinusoid, just one sinusoid. Then what will be V out? It will be G times A sine omega t plus B صح مش كده؟ في سكوير صح؟ ساين سكوير omega t. How many frequency components in the output now? How many frequency components?
3.
هنا we have one frequency omega. طب ومن هنا ساين سكوير
2.
You can decompose it into two DC component and 2 omega صح؟
Yes.
في DC component and 2 omega. What do we conclude from this? If we have a simple nonlinearity, just a second order term, just Bx squared بس أو B input square, and we apply a simple sinusoid with just one frequency, at the output we get a 3 different frequencies. DC, which is omega equal to 0, صح? Fundamental, which is the same frequency as the input, صح? And we call this second harmonic. I hope you have heard about this second
Yes.
harmonic.
Second
Okay,
harmonic.
second.
Yes.
يبقى from one frequency at the input, this is one frequency at the input, we got 3 output frequencies. DC, which is omega equal to 0, and the fundamental frequency, which was at the input, and the second harmonic of the input. And this will give us a simple definition for non-linear system. A system is said to be non-linear if its output frequencies خلي بالك are different from its input frequencies. This is a very simple definition for non-linear systems. A system بصندوق مقفول. How to test whether this system is linear or non-linear? Apply to it a sine wave, an input signal, sinusoidal signal. Check the output. If the output contains the same frequency as the input, this is a linear system. If it contains other frequencies like this, then it is a non-linear system. معي؟ Of course, in amplifiers, we hate the non-linearity. We don't want to see 2 omega and the DC. DC may not be so much bad, but the second harmonic is very bad. Because the second harmonic, when it comes, it will change the sound, for example. Yani this A sine omega t may represent a certain sound. If we add to it its second harmonic, the sound will be distorted. This sort of distortion. Just to give you an idea, if this is a sine wave, how its second harmonic will be drawn? This is a second harmonic. Add this second harmonic to the original fundamental. What you will get? You will get something like this. ومن هنا ينزل ايه؟ يعمل كده. بعدين من هنا يرجع يعمل كده. ويطلع كده. يبقى ده ايه ده؟ This is omega plus مش omega plus 2 omega عشان ما يبقاش التعبير غلط. this is A sine omega t او خلينا نقول كده this is fundamental plus second harmonic وده ايه؟ second harmonic وده ايه؟
fundamental.
fundamental. And I think you can see that by adding the second harmonic to the fundamental, we got a distorted wave. It is not the original sine wave which we know. It is another distorted wave. If this is a sound, the sound we receive will be distorted. Another example, if we have a fundamental and a third harmonic, this is a fundamental. The third harmonic, I hope you have heard about things like this before.
Yes.
أكيد في التيلور as the Fourier series. لكن معلش بلاش. This is a fundamental. This is a third harmonic. Add them together, what we will get? هنا مثلا حاجة بالشكل ده وهنا هينزل كده مش كده؟
هنا هيرجع مرة ثانية.
معلش وهنا هيرجع مرة ثانية أيوه كده وبعدين هنا
increase
هينزل ونفس الشيء هنا برضه يبقى ده إيه ده؟ ده fundamental
plus
plus third harmonic. I think you can see that the wave is very distorted. خلي بالك احنا كمان خدنا third harmonic صغير. لو خدنا third harmonic كبير ممكن تطلع very high distorted. يبقى this is another sort of distortion which is coming from the non-linearity of the amplifier. صح؟ What feedback can do for us if the amplifier is non-linear?
Correct this.
Correct this, as we will see now. We will see it. لكن فاهميني كويس؟ يعني you appreciate now what does it mean non-linear distortion? Is that clear? The result of the non-linear distortion is that the output signal will contain frequencies that do not exist in the input. If the input frequency is pure sine wave, one frequency fundamental, then the output may contain second harmonic if it is a second order nonlinearity, third harmonic if it is a third order nonlinearity, and so on. There are many things to be said about this, but for us in 303 this is enough. Sometimes the nonlinearity is good. Can you guess when it is good? Huh? ما طبعا موديوليشن وفي كمان حتى من الكلام اللي قلناه حتى الان هنا من غير ما اكون عارف اي حاجه ثانيه.
Amplifier samplation.
لا ها if I want to generate a second harmonic يعني I have a frequency say 100 hertz say I need a frequency 200 hertz. How can I get this? A second order nonlinearity. Apply the frequency with 100 hertz to a second order nonlinearity, you can get a frequency which is 200 hertz. Sometimes the nonlinearity is good, it's not always bad. It is not always bad, but for amplifiers it is bad. Because for amplifiers we need equal treatment for the input voltage irrespective of their amplitude, irrespective خلي بالك. استخدمت عملناه في الامتحان. أنا على فكرة صححت الامتحان. فاهمني كويس؟ يبقى إذن don't take a negative position from the non-linearity. Sometimes it is good, sometimes it is bad. It depends on what?
What you want.
No, what do you want? Exactly. I like to hear this. It depends on what do you want. If I want an amplifier, then non-linearity will be very bad. I don't want it. If I need a second harmonic generator, then it is good. And as Ammar said, if I need a modulator, it is very good. I cannot do modulation without كلكم بتاخدوا 370
No.
لا عشان كده انا خفت من الموديوليشن. خلينا في السكند. If I want to generate a second harmonic, صح? Then non-linearity is good.
Yes.
And it is good in many other aspects. Many other aspects. But if I need an amplifier, then nonlinearity is not good, definitely. So what do you think of a statement like this? Nonlinearity is always bad.
Not correct.
Wrong طبعا. Wrong طبعا. مفيش حاجة كده. Nonlinearity is sometimes good, sometimes bad. It depends on what do you want. ماشي؟ And inshallah, if you take 455, you will learn much more about this. But for us, this is enough. So what if this amplifier is not linear? This is to say Z is equal to Gx plus Bx squared. Very simple nonlinearity, but it is nonlinear.
Yes.
And we applied feedback to this amplifier. طبعا this is amplifier. And we applied feedback to this amplifier. What we will get? Yeah? Z بتساوي أو خلينا نقول X على طول تساوي Y minus بيتا Z مش كده؟
Yes.
صح؟ طب what will be Z then? It is G times X plus Bx squared. So it will be G times Y minus beta Z plus B times square this, which is Y square minus أنا آسف معلش بيتا Z سكوير. كنت عايز أعملها في خطوة واحدة معلش كده أحسن. بس عوض Z بتساوي Gx plus Bx سكوير. X بتساوي Y minus beta Z. يبقى G في X, this is X, صح؟ And this is X squared. Try to remove the brackets. So we will get here Z equal to Gy minus beta Z plus By square minus 2B beta sorry في B في Y في Z plus B square beta في Z square.
minus GB.
بيتا سكوير احنا عارفين في حاجه غلط
فين؟
Gy minus beta.
جي بالظبط صح صح حاجه ثانيه غلط او هنا كمان لا ايه ده كده صح كده مفيش حاجه always check whatever. معايا؟ This is an exact expression, no approximation so far. But as usual, we always like to use approximation محمد السريحي. يا أخي ماشي كده حاجة السبت أول اليوم. معايا؟ We always like to do some approximations if there is a need in order to get an expression which is meaningful. صح؟ فهنبتدي نعمل شوية approximations لكنها معقولة. If beta B by the way, what do you expect for B? It is the coefficient of the it is the coefficient of the second order term. صح؟ We expect that in an amplifier which is supposed to be linear, that is exactly exactly. So we expect that an amplifier which is supposed to be linear, then B must be relatively small. مش معقول واحد يجي يعمل ديزاين لامبليفاير ويقول ده لينير وده امبليفاير ويروح يجيب لنا بيتا بي كبيره قوي. لا مش معقول كده. صح؟ يبقى we expect always that B will be a very small quantity. صح؟ خلي بالك بي عندها يونتس. بي هتبقى ايه؟ اليونتس بتاعتها ايه؟ بي عندها يونتس. جي ما عندهاش يونتس لان دي الفولتج جين لكن بي عندها يونتس. اليونتس بتاعتها ايه؟
فولتج
هرتز ايه دخل الهرتز؟
فولتج
ايه دخل الهرتز هنا؟
فولتج
فولت ولا واحد على فولت؟
واحد على فولت.
واحد على فولت لان ده فولت سكوير ده فولت سكوير ده انبوت ده فولت سكوير وده فولت صح؟ يبقى دي لازم تكون واحد على فولت ودي جي دايمنشنلس لان دي الجين صح؟ فاني وات ايفر بي is expected to be relatively small صح؟ طب ادي واحده. And how about beta square? The maximum value of beta is expected to be 1 when I am feeding all the output voltage to the input, صح؟ This is the maximum value of beta. So usually beta is
less than 1.
fraction صح ولا لا؟ less than 1. Beta square will be much less than 1. يعني لو كانت بيتا مثلا نص هتبقى بيتا سكوير 25%. صح ولا لا؟ يبقى can we ignore this part؟
Yes.
هو ده البيتا هتكون
Yes. Yes. Usually beta is less than 1. صح؟ صح. In case if it is not, then we have to recheck our analysis. But we want to reach to a simplified expression, a simple expression which is readable and easy to remember. معنا مش معقول كل مرة تجينا مشكلة نقعد نعمل الاناليسيس ده كله، مش معقول نقعد نعمل 3 و 3 كل مرة، يعني عايزين نطلع من 3 و 3 بحصيلة معلومات مش قليلة لكنها قابلة للتذكر. تقدر تفتكرها طول عمرك، طول ما تشتغل في الالكترونيكس تفتكرها من غير ما تعمل اناليسيس. لكن هنا احنا لازم نعمل اناليسيس. ليه لازم نعمل اناليسيس؟ عشان نقنعك. يعني انا ما ينفعش ادخل هنا واقول لك هي كده وخلاص، هي كده وخلاص، ليه؟ مفيش حاجه اسمها هي كده وخلاص. مفيش حاجه كده. لازم يكون في اساس، صح؟ احنا بنعمل هنا الاساس. As long as you are convinced with what I am saying, then please try to remember these facts all over your life, not only for the exam. For the whole of your life, as long as you are in electronics, then you will need the facts we come up with here. ماشي؟ معايا؟ يبقى إذن it is quite reasonable to ignore this step because B is usually I didn't say always, is usually small and beta square also Muhammad and beta square is usually also small, صح? Smaller than 1. So B times beta square is expected to be a small tail. صح؟ معايا؟ So the rest is take all the Z together يبقى Z في 1 plus G beta plus مش كده؟ من هنا
جي بي بيتا.
مش صح؟
ايه
مش صح مش جي بيتا؟
صح.
وهاخد Z اللي هنا دي هتبقى 2 بيتا في B في Y. كل ده بيساوي ايه؟ جي واي بلس بي واي سكوير. This is an approximate expression, but it is based on obey. It is based on reasonable assumptions. It is based on أهم حاجة هي. You can always do approximations as long as it is based on reasonable assumptions. يعني مش أي حاجة كده مش عاجبانا نعملها approximation ونخلص منها، لا. It must be based on reasonable assumptions. اتفضل يا
How do you know beta only small number?
This is the feedback. This is the feedback. يعني practically speaking, we don't feedback all the output voltage to the end. In some cases, yes, it is, as we will see. In some cases, yes, it is. But generally speaking, beta is small. It is smaller than 1. We don't feedback all the output voltage to the end. In some cases, I said usually, not always. عشان ما حدش يجي يقول انت قلت قبل كده ان beta is always less than 1. I didn't say always. It is usually less than 1. صح؟ يبقى in case B times beta square is much less than 1, which is usually the case, then we can do this approximation. صح؟ In some cases, as we will see together here inshallah, beta may be equal to 1.
في البفر بيتا equals 1.
نعم نعم.
في البفر بيتا.
ايوه ان شاء الله ان شاء الله. شوي ان شاء الله هنيجي لحد شوي. ولذلك انا بتحفظ من الاول. بقول ايه؟ It is usually less than 1. صح؟ لان انا عارف ان sometimes it is 1. It is usually less than 1. يبقى اتفضل.
بس الواحد شوية ده.
في حاجه غلط؟
لا الواحد شوية ده.
من هنا مش دي زد؟ خدت زد مشترك هيبقى في واحد مش كده ولا ايه؟ صح؟ نشوف الدايمنشنز. هنا دايمنشن ليس جي وبيتا بوث ار دايمنشن ليس مش كده؟ بيتا دايمنشن ليس بي دايمنشن 1 اوفر فولت مضروب في فولت يبقى دايمنشن ليس صح؟ جي مضروب في واي يبقى فولتج صح كده؟ وبي 1 اوفر فولت في فولت سكوير يبقى فولت صح دايمنشن صح. This expression looks strange مش كده ولا ايه؟ Because y is involved here and here as well.
Yes.
Because what I want after all, I need a relationship between z and y. which is the relationship of the whole system. The whole system with feedback. This is the whole system with feedback. So I need a relationship between Z and Y. صح? As such, this is not a relationship between Z and Y because Y is involved on both sides. صح? So what I will do, I will write it this way. Z equal to G times Y over 1 plus G في beta plus 2 beta by. ماشي كلامي؟
Plus B
Plus
square.
B times Y square over the same thing. 1 plus G times beta plus 2 beta by. So that so far I did one approximation only. اللي هو ignore the term with Z square.
Yes.
And because I know what I want, I will take 1 plus beta G common. So I will rewrite this as Gy over 1 plus beta G times ايه بقى؟ 1 plus
1 plus 2 by
2 beta by
over
over 1 plus beta G. إذا عملت غلط قول لي اعمل معروف. صح كده؟ أنا أخدت 1 بلس بيتا جي مشترك.
yes.
هتبقى كده. وهنا هعمل نفس الشيء. بلس بي واي سكوير over 1 بلس بيتا جي times 1 بلس 2 بيتا بي واي over 1 بلس بيتا جي. معايا؟ وهعمل ابروكسيميشن تاني. وليه بنعمل ابروكسيميشن تاني؟ عشان نوصل لنتيجه معقوله. ريدبل. We can make use of it. فهقول if يبقى هنا عملنا ده. هقول هنا if ايه؟ if 2 بيتا في بي واي over 1 plus beta G is much smaller than 1. وده معقول ولا مش معقول؟ لأن بيتا وبي الاثنين صغيرين. صح؟ الاثنين صغيرين. فإذا كان ده much smaller than 1 يبقى أقدر أرفع الكسر اللي تحت ده فوق بالنقص. عارفين كده؟ صح؟ 1 over 1 plus x equal to approximately 1 minus x if x is much smaller than 1. The first two terms in terms صح ولا لا؟ يبقى هعمل ايه هنا؟ اكتب هنا خلاص. You don't need it. يبقى what I will get Z equals Gy over 1 plus beta G times 1 minus 2 beta By over 1 plus beta G. ماشي؟ استفدت من ايه؟ من ان 2 بيتا بي في y over 1 plus beta G is much smaller than 1. صح؟ اكتبها ولا واضحه؟ اكتبها احسن. يدينا 1 plus 2 بيتا بي y over 1 plus beta G approximately equals to 1 minus 2 beta by over 1 plus beta G. This is just using the first two terms of the Taylor series expansion of this fraction. Right? Plus by square over 1 plus beta G times 1 minus 2 beta by over 1 plus beta G. نفس الكلام. رفعت الكسر من تحت رفعته فوق باستخدام تايلور سيريز. You agree with me?
yes.
والآن we want to collect terms together. Similar terms we want to collect together. طبعا what is the advantage of what I have done? Now y is always فين؟ فوق صح؟ النيوميريتور باستمرار ما فيش واي في الدينومينيتور لان هنا we cannot do anything with this